Alright, hello everyone, this is Mr. Crozier. I'm going to go over some limits problems here just quickly. Number one, have a graph here and we're looking for the limits to negative infinity. Well, negative infinity is out here, so it's going to 0. Positive infinity is out here, and this graph is going down to negative 4. And these, by the way, are horizontal asymptotes. In behaviors produce horizontal asymptotes. Find the limit here. I did some factoring because plugging in 4 left me with a 0. So I did some factoring. It cancels out nicely. And now I can plug it in and get 2. Intermediate value theorem. Between 0 and 5 right here. The graph goes from 230 down to 175. Is 150 in there? No. Every other number is in here between these two, but 150 is outside of it. 150 is not between those two values. On to the next page. I left this one up here. Common mistake. Which functions are continuous over this interval? A lot of people will say from negative 1 to 3 it is continuous. However, that is a closed bracket. And it is not at 3, so this needed to be an open bracket there. If it is a square bracket, it means it's included. This means it's not included. That's not included, so this is not continuous over that interval. Number 5, is it continuous at negative 1? Well, negative 1's right at this endpoint, the switch between the two graphs. So you got to check both of them, and it does check out. They're both 2. The limit here. If I'm checking for negative 6, I have to come from the left side and the right side, and those values appear to be going to negative 1. Number 7, what values would make it continuous? Well, if you plug in 0 here, which is the break in this piecewise function, it is divided by 0. So that's why it's not defined there. However, if I were to factor that, these all have an x in them, so I could just make it x squared plus 3. Now I could plug in 0. Plugging in 0 would be 15 divided by 3, which would be 5, which means this graph up here, it looks like this, and right at 5, there is this, or sorry, right at 0, there is this hole here. But if I were to take a 5 and put a 5 right there, now I filled in that hole, now it is a continuous graph. So you have to figure out what this hole needed to be, and that needed to be a 5 because it's the limit. I did my limit process here. Just like on this problem, I found a limit. On this problem here, I found the limit was 5. I plugged in the hole with a 5. Number 8. It's asking for the limit. Well, limit means both sides, and this only shows getting closer to 1. It doesn't show the other side. Number 10, straight direct substitution. If you plug in pi over 3, you get exactly what that is right there, so nothing left to be done. Number 9, a lot of work here. The way you can fix this is always multiply by the conjugate. And you can do that in the numerator or denominator, either one. Wherever the radical is, multiplied by that, it'll fix it. Right here, this trig identity, sine of 2x is really 2 sine cosine x here. If you don't know the identities, you could just graph it. If you were just to graph this and look at the graph at that point, right? Take a look at the graph, whatever it looks like, find that point, and at that point the limit will be up here at 2. So you can graph it and see if you don't know the trig identities. Number 12, here's a function. What can we say about x is equal to 2? Will both limits exist? Sure. From the left side and the right side, you do see the limits. Number 2, does the limit exist for both of them together? Well, that's a no. There's a one-sided limit, there's another side limit, left side, right side, but they don't come together, so that one's not true. It is defined there. I mean, right there I have a value of 2, but it's not continuous. 13, the function is defined for all numbers. What's the limit? Well, the limit is up here at 1.7. A lot of people pick that's the limit. That's not the limit. That's the function's value. The limit is there. On these ones, you want to try and reduce as much as you can. Like, let's get rid of these because they're not as significant. And then I have this situation here, and I have 2/3 because the square root of 16 is 4. That's 2/3. And if I plug in infinity now, I'm going to have infinity here is going to be negative, and infinity here is going to be, it's going to lose that negative sign, because when you take it to the 6th power, it's going to be positive, then you square root it, and when you square root the 6th power, you have the 3rd power. So it's going to appear that they're going to be both the same. However, this one has been raised to the 6th power, so the negative's gone. So the negative's gone in this one. So it's still going to be a negative value there. And again, if you can't go through this math, or if you want to double check it, just graph this. Just graph this initial part right here. You will see that the graph goes to this value. Just graph this initial part right here. It will appear like that. On your graph, going out to negative infinity, there's going to be this horizontal asymptote at negative 2/3. Number 15, the function's here. What's the limit? Well, this side looks like it's getting close to 9, negative 9. This side looks like it's getting close to negative 8. Well, those are not the same. There is no limit. These composite functions, we did not put them on the test. You can go back and study these in Khan Academy. You'll get some help. You'll get some good ideas. But I didn't put any of these composites on the quiz, so we won't talk about them now. We're going to simplify this down as much as we can. Talk about what's significant. There's better math we can do for that, but we'll let it go as this. These are significant here. Negative 5x, plug in infinity. Well, that's not going to be bounded. And again, just graph that. If you want to see what this graph looks like, graph this. When you go out to infinity, it's going to go up in forever or down in forever, but it's not going to have an asymptote where it's going to. It diverges. Alright, and number 18. F is continuous function from negative 5 to 0. F of negative 5 is 0. F of 0 is 5. So there's my function. I don't know what it does. Maybe it goes like that. Well, what do I know? Do I know there's a value of negative 2? No, negative 2 down here. But I do know there has to be a value of 2. You can't go from 0 up to 5 without crossing 2. These are the wrong ones, and those are the wrong ones there. So if you want to go from this point to this point, you have to cross 2, not negative 2. The value here, just finding a limit of 1. Well, it's kind of a trick problem because I gave you this piecewise function, but the value 1 is solely in this graph right here. It's only in that part, so we just direct substitute it in there. Instead of ln of x, I have ln of 1 is equal to what value? Well, that's e to the c is 1. Well, that's 0 power. Alright, and the last one, I can't factor this 3 out. So we know it's not a whole, we know it's an asymptote. So it's either going up to infinity or down to infinity. You can graph it and see they're going up, but the only choice we had was the limit does not exist. You could try some test values, put them in there, make yourself a chart. You could graph it. You'll see that there is no limit for those ones. Alright, this is pretty much what your quiz is going to be like. If you have any questions, I will see you in class.